Welcome, everyone. The event is now live. John, please take it away.
Hi, everyone. Welcome to the AWS Cloud Security Summit. Today's event was organized by the hardworking folks at AWS Insider and Virtualization Cloud Review, who have brought together some of the best independent experts on today's topic. Many thanks to our sponsor, Red Hat, the world's leading provider of enterprise open source solutions, including high-performing Linux, cloud, container, and Kubernetes technologies, for making this event possible. And thanks to you for joining us. I'm John K. Waters, Editor-in-Chief of Application Development Trends, and I'll be your moderator for the first of 3 information-packed sessions. But before we get started, I need to go over a few housekeeping details. Each of today's sessions is being recorded for later access. Keep an eye out for an email with a link to that recording. It'll be coming your way within the next few days. Each of today's sessions will be followed by a 5 to 10-minute Q&A. You can type your questions into the Q&A box at any time. Please feel free to add your questions as they occur to you throughout the summit. We'll do our best to get to all of them. Our sponsor, Red Hat, has provided some extra resources that can be found on the right-hand side of your screen. Please take a moment to check those out. As you leave the summit today, you'll be asked to take a very short survey. Please take a moment to share your honest opinions. Our editors read every comment, and they help to shape our future events. And last but not least, at the end of the 3rd session, one lucky attendee will be receiving a GoPro Hero 9 action camera. But you must be present to win, so stick with us. Now let's get started with our first session, the new security realities of your AWS cloud infrastructure. For this session, we've called on Ian Thornton-Trump, Chief Information Security Officer at Cyjax. Ian is an ITIL certified information technology professional with 25 years experience in IT and cybersecurity. He served in the military intelligence branch of the Canadian Forces, the Canadian Forces Military Police, and the RCMP, where he was a criminal intelligence analyst. His experience and ongoing research have made him a sought-after cybersecurity consultant for multinational insurance, banking, and regional healthcare organizations. He also teaches cybersecurity and IT business courses as a member of the Computing Technology Industry Association's global faculty. And he's the lead architect for CyberTitan, Canada's effort to encourage the next generation of cyber professionals. Needless to say, Ian has a great depth of experience with the threats facing small, medium, and large enterprises today. He comes to us live today from the DTX conference. I know you're in for a great session. Take it away, Ian.
Thank you, John. And once again, it's wonderful to be here and talk about topics that are near and dear to my heart. I just would be remiss in not reminding everyone that we have a virtual conference going called BeerCon 3, 28th to 29th October 2021, where we've got all sorts of top name and some speakers that you haven't heard of at all. One of the things that John pointed out, rightly so, was in the resources section, I had my team at Cyjax put together a threat intelligence report on containers, cloud services, security. So please check that out. All right, now as we kick off, one of the things that I maintain is that a properly architected and provisioned application running in the cloud environment like Amazon will be more secure than running it anywhere else. Now, that is a pretty bold statement, and my job today is to try and back that up with some reasoning, some thoughts, and a massive shout-out to Red Hat as well, which we'll get into why that plays a really important point in this whole story. Now, the other thing I want to point out is that this is not about cloud pricing. Okay, this is probably one of the hardest things to nail down is what are the costs involved of doing something in the cloud today. If you are at all interested, please check out the Amazon.com pricing and try that calculator that they've provided because it's complex or it can be a very rude surprise when you start turning things on or where you find in your requirements to deliver applications via the cloud on some of the technology platforms, it can be pretty darn expensive indeed. So really important to understand that equal weight to all of the things that go into migrating applications to Amazon, building fresh in Amazon, All of those things are got to be factored into your program of works in your project itself. But also pricing really needs to be figured out, because there are many business cases out there that will point you in the direction of possibly hybrid if your organization has already made a big investment in boxes, or some sort of other combination of hosting and hosting provider. Just the other month, I did a webinar on the hybrid realities in terms of security, and these are existing, I would say, templates that businesses are using in order to maximize both their technology on-premise investment and into the cloud. So being in the cloud can have a lot of different meanings for a lot of different people. It can be your front end is there, or your back end is there, or your data science capabilities are there, or you've actually built a SaaS offering that you offer to other people that is all hosted in the cloud. No word on the big InfoSec story of the day of whether or not a cloud hosting provider was popped or accounts were popped in the big Twitch data breach that everybody here at DTX here in London, one of our first physical conferences in 2 years, was involved. And I'm sure, watching that situation carefully, we need to understand, was it a repo or was it an actual production environment that might have been compromised? So a lot of people are turned off the cloud because of that very reason, that everything that we're going to talk about today has some sort of cost associated with it. Again, platforms of choice here. Some folks are really tied into to Azure because, it supports the .NET development environment very easily. Not saying that Amazon doesn't support Microsoft Stack. I mean, you can build Microsoft servers in Amazon, of course. But, some people prefer to leverage their Azure investment or are more comfortable in that development shop. I think Amazon's reputation has really been around running open source software like Red Hat and seeing sort of application development move in an open source kind of direction, along with using some of the, most recent frameworks like Django and others. So I think, it can be said that if we look at this from a holistic perspective, we're really talking about the OS and application layer today, and not necessarily the under the hood stuff. But we're gonna talk a little bit more about that. So I think that it's fair to say with these hosting infrastructures that AWS is probably the world's second biggest machine we have ever built that has been built by mankind. And I would also suggest that the first largest thing that we've ever built has been the internet itself. Amazon right now, literally their largest customer, I believe, is Netflix with 100,000 server instances. To give you a perspective, somebody told me that there were 3.5 petabytes of data that Netflix uses in terms of all of their HD movies, and some offered in SD, et cetera, et cetera. And when you combine Netflix, which is running on the Amazon infrastructure, and you talk about Amazon Prime Video, you've got basically 3/4 of the entire content of the world on those platforms. So it's pretty massive. It's an absolute massive commitment to build and secure and maintain. Now, Amazon has 11 certifications, including a dedicated security one and dozens of free courses. So one of the things that's really important as part of your project plan to really start building security into the very beginnings of your development or your product, of your life cycle, or of your application migration is to really take a look at those courses. And this is something that I'm going to harp on quite a bit. Now, the attack surface of Amazon is quite prolific, and it happens quite a bit. And that is another factor of being in the cloud. And a lot of these attacks have to do with compromised keys and compromised credentials and the lack of multi-factor authentication, which is a native Amazon service, by the way. All you need to do is turn it on and use either the Amazon Authenticator or a multi-factor authentication of your choice, including hardware tokens, to secure your infrastructure. But I pointed out to these headlines because it's really important to see that this attack surface has been around for a very long time. no one needs to be surprised that people want to break into your Amazon. I've talked to dozens of companies that have lost their accounts, and it has been basically leveraged into a giant Bitcoin manufacturing system in order to try and make things difficult for the organization. And sometimes the stealthy activity was so good back in the day with the lack of logging that the bad guys would come back. They would continue to enter the business through their Amazon credentials, spin up crypto mining infrastructure, and then guess what? Exfiltrate all of that out of the business and return everything over long weekends and over weekends when maybe operations wasn't paying attention. The actual ability now to monitor your Amazon resources and Amazon spend is probably the number one feature that you need to be paying attention to in terms of like managing your Amazon infrastructure. And all of the tools now are there to do it, along with a huge investment that they made in cybersecurity. And we can see from some of the dates there that these threats go back all the way into 2013. But you know, I would be remiss in not throwing a little bit of cyber threat intelligence into you. Again, we released a report on the vulnerabilities of the cyber infrastructure, and the biggest vulnerability right now is coming in from a group of operators called Team TNT, who continues and relentlessly attacking the cloud, grabbing Amazon credentials, grabbing keys from repos and things like that, and breaking their way into Kubernetes and other poorly secured infrastructure. There's lots of research material out there, but this is the example of, in the cyber criminal underground, an actor basically has been scripted or has a botnet that was grabbing credentials from the organizations and using them to exploit and gain access to the systems and allowing other folks to potentially launch a ransomware attack on their AWS infrastructure in hopes of selling those credentials on the dark market. So again, the threat actors are out there. Please read the included report that we put there. Now, this is a big one, folks, that I really look at, at the high level. Now, the modern DDoS capabilities of botnets is truly ferocious, okay? We're talking about attacks that are record-setting in terms of security. So Amazon last year fought off a 2.3 terabit per second DDoS attack on one of their customers that they had. Now that is an absolutely crazy high-level attack that, interestingly enough, protection for that attack, free, okay? Now, you do have to pay for the actual service itself, but you don't have to pay per, gigabyte or megabyte of attack on the infrastructure. So this is the kind of thing where if we can do one thing, if we can take away from this presentation, is let's make DDoS a thing of the past. Now, why is this important? If you have mission-critical applications and people, lives depend on it, or it is a massive system that you have, putting it into the cloud makes a lot of sense unless you have huge amounts of money to build your own data center with all of the redundancies that you need in front of it, and possibly, purchase something like Cloudflare, et cetera, And now all of a sudden what you have to do is essentially replicate what Amazon has already built for you. And it's quite expensive to do that. The other problem with hosting on your own infrastructure, your own mission-critical applications, is you don't have that level of redundancy. You will have to purchase and build that level of redundancy into your own organization. So Amazon actually, when you look at it, yes, it's expensive, but when you actually look at the total cost of your security infrastructure, of what you would need to do to deliver a mission-critical application and mitigate a frequent attack like denial of service, you would have to invest a tremendous amount of money. So this is one of the immediate advantages that comes out. I mean, fact of the matter is that Amazon does have a 24/7, 365 multi-regional operations center looking to take the fight to the bad guys when they see these types of attacks coming at the infrastructure. And they have amazing capabilities that are basically included in that price. So again, when discussing cloud, think of total cost of ownership, and we're going to get into what that looks like. So This is a super important diagram that you find in a lot of the discussions around Amazon and AWS and the customer's responsibilities are. I think this is brilliant to have that conversation because reality is this. There are things, expensive things that need to be done within an organization that Amazon is looking after you up and to the point where you start building on their framework, right? So what are they doing? They're doing things like hardware management, firmware management, a lot of load balancing replication, a lot of services, inter-services that they're providing an encrypted layer for that you don't have to architect at your application layer. One Amazon server in a data center talking to another Amazon server in the data center is, according to the research I did, a encrypted connection. So again, that will take a lot of layers of complexity out of your infrastructure development by making sure that when you're dealing with a on-premise solution where you're hosting, a database and a server, you have to look at having something like TLS between the two in order to secure it, especially if it contains sensitive customer information or sensitive employee information. So again, Amazon is providing a platform for you to build on, and they are putting in the right tools and the right techniques at the very bottom of it. This is why I say that for organizations that are, coming into their own in terms of maturity for a secure application development lifecycle, a lot of that operational stuff is pushed down the stack to organizations. Now again, though, this does not absolve the customer of the responsibility on the upper part of it, right? And we all seen this situation, like if you're driving your car and you haven't taken it for a vehicle inspection and you have balding tires and bad brakes and you get into an accident, well, it was pretty much a foregone solution, right? So Amazon has got expectations that the customer know what the heck they're doing within their platform. And it's not like it's a mystery. Back in the day, it was. There was very little support for customers coming in, but they have massively scaled and made a huge investment. Now, this slide, the important takeaway here is there is a security course dedicated to Amazon infrastructure and understanding the security concerns and going at a high level through some of the stuff that I'm talking about today, but also get into the nitty-gritty. And I think at least someone in your organization, if you're contemplating moving to Amazon or having Amazon services implemented, please get the security qualification as part of your team and make sure that that individual is at the table when you start discussing the application architecture. And again, the other three certifications speak to that directly. Architecture, DevOps, and the actual provisioning part of the Amazon environment, right? Where you start looking at things like Puppet or container replication or other pieces of software that help you manage that infrastructure and build it to scale and build it to scale securely. So what is the big security problem with AWS? People don't know what they're doing. This is what we see time and time again, right? And again, pointing out AWS itself has that global SOC capability, and the AWS Cloud Marketplace for security solutions for customers to look at things that might be specific in terms of application control, in terms of like monitoring and management of the infrastructure. And again, I mentioned Puppet and I mentioned other types of software. There's good friends from Five Nines in terms of backup support. But also what you're really looking at too is solutions that bring you closer to your mission of visibility, compliance, and operational security so that you have the necessary data that you can treat it like it is on-prem, like you have control of the information and you have a logging solution in place, or you have something like Splunk deployed that is actually relying on elastic clusters and stuff like that. So you have a great opportunity within the Amazon ecosystem of using and deploying different tools at will to fulfill those compliance and security requirements. And I think the big takeaway from this is do not start disabling to make it work, okay? This is what got us into a whole heap of trouble, and it continues to be a whole heap of trouble when you see all of this personal sensitive data exposed, and a great resource for that to Google yourself and to see if kind of you have data exposure in somebody else's S3 bucket is the great folks at Grey Hot Warfare, which are on the radar of every, I would say, operational security team that's out there. Because a data exposure is bad for your business, of course, but it's also bad for your supply chain partners. I think it's incredibly important that you take the responsibility of making sure that your S3 buckets are not exposed. And to be fair, Amazon has done a tremendous amount of work on making sure that you're painfully aware of disabling security and making stuff globally available when you're using S3 buckets. It used to be a bit esoteric, and that's why we still have millions upon millions of records that are publicly exposed. And so I think as part of your whole cyber threat intelligence program, keeping an eye on and building alerts with a tool like Grey Hat Warfare on any public exposure of your company's brand or company's brands is truly important. Now, I highlighted the customer responsibility matrix here because, to be fair to all the people working in IT out there, our brothers and sisters that are working in IT operations with the physical server infrastructure, a lot of that power and control, of course, as I said, is devolved into AWS itself. But it does not let the customer off in terms of responsibility, okay, to protect those credentials, to make sure that your operating systems, if you're running instances, are patched and updated to the latest versions, that you're applying the necessary best practices, right? Amazon doesn't police you do in their infrastructure to a certain extent. Okay, like if you're doing something highly disruptive to their infrastructure, they will come down on you on a type of bricks. But they aren't going to advise you whether or not you've got something that's vulnerable or something that's poorly architected. Sometimes they will advise you if there's been an exposure, and that's normally because some good net citizen out there has encountered one of your S3 buckets or an S2 instance that has been made publicly available by accident. Misconfiguration is a reality, and again, that's why I urge everyone to get that security qualification if you're working with the cloud and be early at the project table to ensure that security is part of the DNA of any architecture that you're putting up there. The other thing I want to talk a little bit about is the instance management really becomes key in Amazon. So I'll give you an example. Using snapshots of servers is a heck of a lot easier in a virtualized environment. Amazon, fair game, even if you have your own virtual infrastructure, you basically have the ability to do snapshots before you apply all of the patches and updates. That is absolutely critical. I prefer to have a dev environment denuded, if you will, of customer data that can be used to test the patches before you deploy them into the production environment. Some folks are a little bit maybe too trusting, and they're just saying, okay, we're just going to patch critical security vulnerabilities, and, away we go. The other thing you have to understand is the differences in the physical reality of the operating system. You're not going to be able to use things like USB tokens that, were the software licensing mechanism back in the day. So there are a few things that are going to allow you that you must maintain, your on-premise infrastructure for certain applications, and that virtualization is an absolutely huge and difficult challenge. Fair enough. The actual reality, though, is you need to manage this infrastructure like you would manage your on-premise infrastructure. In order to do that, DevSec or DevSecOps or DevOps really needs to understand the technology that they're using and make sure that they've got the proper security controls in place so that they can recover from the infamous bad patch or the infamous .NET update that knocks out, TLS connections between certain applications that weren't specifically calling for a version of TLS like the latest version. So this is a reality of, patching boxes or taking a haphazard approach to vulnerability management. And unfortunately, in some operating systems, certainly Windows is guilty of this, undoing or rolling back a patch sometimes can be extremely challenging. So sometimes it's way easier to just restore from one of your Amazon snapshots that you made. So this is the thing that I talked about that is like the big bugbear in, I would say, application development right now. It's the fact that we want to get data encryption at rest and data encryption in transit, and we want the big shiny checkmark box for those challenges. Now, there is a lot of stuff under the hood that AWS already does, right? So they have those data at rest encryption capabilities, right, for most of the AWS services. You need to understand, learn how to deploy it, learn how to use it. And again, Amazon courses to the rescue, great YouTube videos on it, great support available from it. And of course, if you have a vendor on support, like our amazing friends at Red Hat, they will be able to advise you. Because quite frankly, I'm pretty sure when it comes to deployment of Red Hat into Amazon, you are not the first person ever taking on that challenge, all right? They have done it tens of thousands. So there's a lot of institutional knowledge in your vendors. They might even have documents to provide you in terms of best practices. In fact, I know they have documents to provide you in terms of best practices. So that's really important. And then the other big thing, and this is where those bad guys again are targeting, is key management. Within minutes of exposing a private key in a repo, you can expect hackers to be trying to go after that infrastructure and try to own it or try to do malicious things. Mostly now, it's not crypto mining, it's more like ransomwaring the organization and making life truly difficult for them and demanding a massive ransomware payment, especially if you don't have good DR BCP capabilities within your organization. So make sure that you're managing those keys like the keys to the castle that they are, and that you have deployed multi-factor authentication on getting into your instances. And I know some organizations only access the Amazon infrastructure from a Bastion host, a host that has a virtual network card in the Amazon infrastructure and a host that has a virtual IP or a physical IP in your own infrastructure to make sure that there's only one conduit to get into the management console and the provisioning consoles and things like that. So it can be locked down really successfully. Now, a big part in cyber crime right now, and this is like for everyone out there building applications, managing the infrastructure, it's IAM, man. Identity access management is the new battleground in cyber criminal operations. We see time and time again phishing campaigns designed to steal credentials. Credential theft is I would say, becoming a bigger peril than email attachment or even the link sent to you in email. The big providers are getting good at blocking and scanning that stuff. Not saying they're perfect, but I am saying that we don't see a lot of the phishing emails now that we used to do, that the providers are getting better. This is why this is critical. There's two mistakes that a lot of people make here. One is trying to roll their own implementation of identity or access controls, and usually it's a dangerous game unless you happen to be one of the top people in the world that understands all the nuances of cryptography and knows how to program an application solidly, right? Am I scaring you? Well, I'm meant to, right? What you really want to try and do is focus on that identity and access control capability that is built right into the Amazon stack, right into the services that you can use, okay? And I think when you think about the ways that you're going to manage cloud access, of course, you can't be thinking that single sign-on or Active Directory is not the solution. I'm a huge believer in single sign-on protected by multi-factor authentication. And when we see and diagnose some of the big attacks that have happened where email accounts have been compromised, especially in the wake of the SolarWinds data breach, where many states' attorneys and Department of Justice folks ended up getting owned by the bad guys, this was because multi-factor authentication was either defeated by a weakness called the golden token, or it was never activated in the first place. And I'm telling you, once you gain access to an organization's Amazon infrastructure, it says bad news is gaining access to that organization's email. This is why account provisioning, I think, needs to be driven from a single source of truth in an organization. So integrate with your payroll system and make sure that payroll kicks off scripts, maybe basis that provision provisions the organization according to the best practices and role-based authentication requirements of that particular individual user in that particular group. All of this type of stuff, single sign-on, Active Directory integration, identity and access management, including the ability to detect when something is not doing what it's supposed to be doing, i.e. login failures, is all built right into the Amazon stack so that you don't have to try and do the worst thing in the world, which is roll your own, right? It's all right there for you. Now, a big deal has been made about monitoring and logging these days. Now, in pure play cloud environments, you've got those capabilities of like CloudTrail and CloudWatch and GuardDuty, a lot of things built in. And again, there's services that you have to activate, and I do believe they cost money to have deployed. And yes, right out of the box, they provide brilliant security and compliance capabilities, right? But, you know, as time evolves and you find that your business cases and your user stories and all of the other things that drive application development evolve, that's where you're going to have to look maybe beyond some of these capabilities. But what I'm saying is a baseline for your organization, again, you should know what they are, you should know how to deploy and use them, and you should know that the fact that they're there in the ecosystem of Amazon just waiting to be turned on to use. And I'm sure if you go and develop a relationship with Amazon and talk to them, they can advise you as to where sometimes their offering might fall short. But, you know, we're at the 80-20 rule of cybersecurity now, and most of the companies that we've seen that have gotten breached over the last little while have been breached as a result of failing to even turn on or these options in their application development. And it's a crying shame. I mean, to think for a moment there, if you just flip one switch or deploy one service into your infrastructure, you would shut down an attack that threatens to compromise the operations of your company. It's amazing to me that more isn't done in this area to encourage people to at least take the out-of-the-box solutions for the organization. So I want to now pivot a little bit and talk about what's going on under the hood and what Amazon is doing. So their capabilities are phenomenal when it comes to dealing with hardware faults, dealing with system faults. You know, everybody can poke their finger and talk a little bit about, you know, failures, et cetera, et cetera. But the reality is again, as the second largest machine in the world, I think they're doing a superbly good job and providing tremendous value for an organization looking for a secure platform to build upon. And I'm going to say that again, secure platform to build upon. This is probably the number one problem that we face in cybersecurity, right? Is, of course, not having a robust platform to build on, right? And, you know, when you really think about it with most organizations, can you really hold your hand up and say, you know what, we've never had an outage, we've never had any downtime? You know, to be honest, the machines are built by humans. Humans have flaws, and human edge router teams working at Facebook, for instance, might make dumb choices. So dumb, in fact, that they actually needed to get access to the physical infrastructure in order to manage their incident response and bring their entire edge routing back to life. So this happens to everyone. But I think that Amazon really has done an amazing job of stepping up to the plate, of telling you globally what's wrong, what the health is. Now, to kind of poke a little bit of fun at Amazon, what a lot of organizations don't understand is regional capabilities and failover. Yes, does it sometimes cost double the cost, you know, to build what you have in another region? Absolutely it does. But if New York 1 goes down and takes out, you know, a whole bunch of big businesses and big customers, maybe you have to ask yourself, what is your revenue per hour? What is your revenue per minute in some cases? Would it be worthwhile having cold start capability or being able to push your repo and rebuild your infrastructure into another region almost simultaneously when there's downtime, and update your global routing in order for people to be able to find you online? I think the amazing capabilities of moving your infrastructure between regions is probably one of the underutilized resources that Amazon can provide, and especially for mission-critical applications. I think if you don't have DRBCP that's measured in minutes, you may be really, really challenged, and the only way that you might be able to do it is by replicating your infrastructure into another region and just being able to flip a switch and setting up replication jobs. So yeah, maybe you will lose a couple thousand transactions as the new system comes online, but that's a hell of a lot better than being down for several hours when your organization measures their income in tenths of a second. So that's the human factor. Now, I'm going to get, as we wrap up, and we're going to end probably in about 10 minutes, so please get your questions in. Please download the resources that we've provided to really help. Where do I see all of this going forward? Well, I think the first is that an application that's poorly architected or is vulnerable on a platform, it's irrelevant who has, right? It could be a cloud hosting provider, it could be Google, it could be Microsoft, it could be Amazon. But if your application has fundamental design flaws in it, then putting it into the cloud environment isn't really going to benefit. In some cases, take the opportunity to look at re-architecting components of it, updating libraries before you start migrating it into the platform of your choice, like Amazon. Because I'll tell you this, it's a lot harder to take an unstable application and put it into a cloud hosting environment, only to discover that there's some back-end services and back-end resources that you were very unaware of. This is why architecture and discovery is critical for your success when you are moving information from your on-premise environment or scaling an application up to cloud levels. So again, keep that in consideration. Again, I can't underscore this enough. Certifications. And the certifications do really two things. One, educate you about how to do things right, which is, of course, critical. But two, it gives you some credibility within your own organization and the assurance of your executive team that you're taking all the necessary steps out there to make sure that your cloud environment is as protected as it can be. And getting those certifications are the only way to assure your own executive stakeholders, your own project stakeholders, that you know what the heck you're doing, right? This is a big one for me, and it's a really interesting juxtaposition. So ensure staging and perhaps development are as close to or as scaled down versions of your production environment. This is absolutely critical because I've seen too many times where something works in staging or works in development, but then when it's scaled into prod, it just falls apart completely, and there's usually a downtime, especially if the organization hasn't rigorous DevOps controls involved in, like, do a snapshot, apply it, do a bunch of tests in production to make sure it works, and then, give everyone the heads up that it can go. Now, a lot of these disruptive events occur not necessarily because of a mistake in code or things like that, but at scale, when you go from, a script that tries, 1,000 transactions or 5,000 transactions against your database, and that seems to be okay in the QA environment, wherever you're QAing, maybe instead in staging or in the development environment itself. But then when it scales to 50,000, there's a memory bug or there's a piece of code that, even though it has passed all your SAT and DSAT testing, what happens is you find that bug as soon as it's hit with that massive scale of requests. These things happen. They're difficult to track down, and, times you're going to be rolling back infrastructure, and sadly, if you don't have the right monitoring solution in place, it's because your customers are going berserk and calling you, right? You're the last ones to find out that you have a massive performance issue in your infrastructure. And again, as part of that Amazon workplace, if availability is like the number one thing that you're after with your infrastructure in the Amazon environment, you need to have some sort of comprehensive application management, application monitoring tool in place. Now, I say this with sort of a grain of salt because testing in production, pen testing in production, is kind of a no-no. Amazon has gotten a lot better and has been a lot more cooperative than it used to be. It used to be like a vicious guard dog if so much as any sort of thing that looked like a SQL injection attack was happening on their infrastructure. They've evolved a little bit now and are doing it a little bit on a little bit more on a case-by-case basis. But if you get on their radar, you can expect some pretty harsh treatment if it looks like you're conducting a cyber attack either inside their infrastructure or against their infrastructure. And so, again, does the customer have an operational responsibility, to monitor the Amazon infrastructure with their SOC? Of course they do. Not doing that is basically not being due diligent. But at the same time, Amazon is watching. They're watching for dangerous things that could impact not just them, but others. So I included the link. It's incredibly important. I'm sure they stressed this in all of the courses to make sure that if you are going to pen test a production environment or even a development environment that's in Amazon, you have to make sure that it conforms to their standards. And it's also a great idea to give them the heads up that this is going to be occurring, because otherwise it may have unintended consequences. And unintended consequences can include the blacklisting of your own corporate IP address if they see the security team blasting away at the Amazon infrastructure with some nastiness. So keep that in mind, because it's going to be a real bad day for you if your corporate IP address is blacklisted, all right? Because you conducted, and did some unauthorized things on the Amazon infrastructure, and they will come after you for that. So, word of caution there when you're playing with fire. Now, I have some top tips. Absolutely, CDNs are a valuable piece of, high availability websites, 100%. But please deploy that Windows application firewall or a product that does web application firewall. Please deploy a web application firewall in front of your applications, even if you've tested them, even if you're 100% sure that it can't be owned, because sometimes there are vulnerabilities that come up, like especially with PHP or the Apache one right now that's under attack. A good web application firewall can immediately get an update and be told that this is a hostile attack and block it before it rips apart your infrastructure. So again, web application firewalls for the win, FTW as we like to say. I think, too, when you start to look at the cloud, it really has to percolate down into your organization. The cyber threat intelligence team, if you have that capability in-house or you've outsourced it, needs to be aware that you are a Amazon or Azure or a Google customer so that they can build that, they can threat model it, they can come up with the appropriate controls working with compliance, and maybe even give you some guidance on what the best practices are out there in terms of deployment of both compliance and security tools. And I think the thing is you do need that integrity monitoring, especially if it's a mission-critical application, especially if it's controlling sensitive data, and of course vulnerability scanning has not gone away. But again, use with caution on cloud providers' infrastructure, because they can get a little bit aggressive in protecting that infrastructure, especially if they see a whole bunch of things that look like attempts to exploit, right? Firing up your Metasploit and running it against Amazon boxes is probably not in the best interest of having a harmonious relationship with a cloud provider, any cloud provider. Another critical issue is certainly in those staging and development environments, do obfuscate or do create data sets that don't have any customer data in them. This is only because in a lot of cases the security may be lax in the development or staging environments, but I do recommend that if you're going to do type of things, you need that comprehensive logging in the development and staging environment so you can see if things are going wrong or sideways, or if you're under attack in those environments if they're not secured to the same level as your production environment. Because we've all talked about that supply chain situation that goes way back before even the SolarWinds data breach, but I'm talking about way back into the CC Cleaner exploits and a Chinese threat actor group called ShadowPad that deployed malware within those development staging environments that managed to get deployed into production builds, right? And again, look at your DR BCP testing. Really work hard to make sure that you understand, what DR is, what business continuity planning is, what the expectations of the organization are, and then architect it accordingly. If they want, the mythical 5 nines, but if they want, high availability because it's critical application, and if it fails, it has huge revenue repercussions to the organization. It's up to you to make the case for multi-regional deployment in order to be able to move regions if there's a major outage or a major impactful event that causes your organization to flounder a bit. And then finally, play the vendor game, okay? Use the security features that are provided by Amazon. As time moves on, discover the better, the faster, the less expensive, highlighted there. Shop the marketplace and understand that your vendors are out there, like the good folks at Red Hat, to support you, and you are not doing something probably for the first time in the Amazon environment. There's tons of great support and tons of great people out there to help you on that journey of being successful with the application deployment into the Amazon AWS framework. And again, my quote, which you can read, if you want to follow me on Twitter at @FatHobbit, the best way to get the best Amazon Web Services advice is to talk to someone that knows what they are doing. All right, and with that, I turn this over live from DTX. I do apologize for the raucous music that you might be hearing in the background. I hope it wasn't too distracting. John, over to you.
Thanks, Ian. Now let's get to some questions for our attendees. Remember, you can type your questions into the Q&A box at any time. We'll do our best to get to all of them. So Thomas asks, I have read the responsibility matrix for CSPs and clients. Do you see changes and or updates occurring?
Yes, in the terms and conditions to further isolate the major providers from any sort of upstream liability whatsoever. I mean, this is right now the most hostile internet that I've ever seen in my life. I think there's going to be a lot more discussions around it, potential litigation around it, when we're talking about the massive penalties that organizations face and the massive class actions that the organizations face from data breach. So I think it's only natural that there's going to be more clarity, more differentiation, and more litigation in our futures.
Okay, Gina asks, we are running a hybrid Azure AD with syncs with our local AD and Microsoft 365. You mentioned WAF. Is a web firewall recommended if custom applications are not deployed?
So, obviously you want to have some good, solid AD allow, deny rules going on in terms of like your exposure, but that is the correct way, in my opinion, to do Active Directory. Back in the day when Microsoft first brought in Azure Active Directory, it didn't work well. It's a lot from availability issues and the Microsoft end of things in the cloud. Hybrid AD, in my opinion, is absolutely the way to go, so that if connectivity gets knocked out or if there's some sort of issue and crashed credentials are no longer doing it for you because the application is more dependent on a real-time authentication mechanism as opposed to an offline authentication mechanism. Active Directory synchronization is the way to do, but again, lock it down, use the tools, make sure you go to the resource center in Microsoft about securing Azure Active Directory in the cloud. Again, make sure you have explicit firewall rules built on your end, because you know what a bad day is, John? Exposing your entire AD to the internet. That is a bad day.
Right. That's a bad day. Okay, here's another one. You talked about how vulnerability management in the cloud is a shared responsibility. What specific things should a customer worry about?
Well, it's interesting because especially when we saw those attacks like Rowhammer that were able to get beyond the hypervisor and into the nitty-gritty, and then we see cPanel vulnerabilities or cPane vulnerabilities and things like that, that is 100% on the shoulders of the provider, right? And in a lot of cases, Amazon has that capability of patching a major operating system issue with, the hypervisor environment in hours, as opposed to what might take days in other organizations. So they take that stuff really, really seriously. In terms of the OS stack, though, that's on the customers generally. In terms of the application running on top of the OS, again, that is your responsibility. Now, Amazon is pretty benevolent in that it do have, of course, edge security capability, and they do block a lot of attacks into and out of their own organization. So they're not being what I would say, total freewheeling about it, but they're certainly not saying, don't just rely on us. That's kind of unfair of you to do to Amazon, but also they could be looking the other way. They've got a giant infrastructure to manage.
Okay, here's another one. If credentials are compromised and SSO is enabled, does that not give malicious actors full access to the Amazon infrastructure?
Potentially, absolutely. This is why, I'll say it again, multi-factor authentication for the win. Because you know what? If you're getting text messages with 6-digit account codes at 3 a.m., you know you have a problem. And then, of course, you go to your email and have has emailed you to say that your organization has a bunch of publicly disclosed data breach, including passwords, which, unfortunately doesn't happen as often, but it sure happened to Fortinet and Pulse VPN and SonicWall a little while ago. And that could have been disastrous to organizations that were SSO without MFA.
Fascinating. Okay, how about this one? What's the difference between access control and security groups?
Yeah, that is a lower level thing. I mean, and I would say go on the security course and figure it out. But I will give you the lowdown on this. Okay, so a security group is part of the Amazon environment that basically dictates what account has access to what resources within the Amazon environment itself. Right. You can create, don't do this, but you can be a root user and you're protecting access to the organization based on the level of access that you're providing in the security group itself, all right? Access control lists prevent people from logging in from the global infrastructure into your infrastructure. Now, why does that become important? Because occasionally a unsecured service or an old service is exposed. So I use the example of an SSH daemon running on an older operating system that isn't vendor supported anymore, okay? You can do that. But the problem is if you're not using an access control list to prevent that SSH daemon from being accessed anywhere in the world, then you're exposing it to a potential interpreter and vulnerability where you could get that box owned, and means potentially the bad guys can move laterally through your entire Amazon infrastructure, thus necessitating a call to your very grumpy CISO about how the fact of the matter is you don't own your Amazon environment anymore. Now, the good folks at Amazon will see your emergency flare, and you will be able to call them, and they will give you some advice and counsel and gently tell you what you did wrong.
Okay, looks like we have time for one more question, and this is one that I get kind of a lot too. And you mentioned DevOps and DevSecOps. I'm a little confused by the two terms. Can you clarify? What's the difference?
Absolutely. So DevOps used to be really focused on availability and operational provisioning of the environment. DevSecOps is now, I would say, the security responsibility for that operational and availability environment is now heaped upon them. This is sort of what I'm going to call sort of a modern evolution. The next evolution is to have a security, a threat intel feed driving the activity of the DevSecOps team. So imagine your current ops team and add, a spicy blend of security, and now what you have is a bunch of guard dogs not only keeping the system available, not only keeping it humming and patched and up to date, but also being on the lookout for attacks coming in. Some people are now putting a threat hunting component into the DevSecOps because let's face it, if you're putting something into the Amazon cloud, you want it protected. You're probably even dealing with some sensitive information, or you have a giant repository of customer data that you're doing data science with. You need those pit bulls guarding that operational capability with the right security tools deployed, with threat hunting capability, intelligence-led, in order to very best chance of defeating any cyber attack on your infrastructure before it even happens.
A spicy blend. I love that. Okay.
Spicy blend.
That's all the time we have for. Thanks, Ian, for an absolutely great session. It's always such a pleasure. And thanks to our sponsor, Red Hat, for making this session possible.
Thanks, John.
Okay. You bet. Have a great conference. Ian came to us today from the DTX conference live. We appreciate his time today. We're going to take a short break, but we'll be back at the top of the hour for our second session, AWS Security, Backup and Recovery Best Practices, led by Carlos Rivas, Senior Solutions Architect at Intervision Systems, and led by my colleague, David Rammel, who leads the editorial team at Virtualization and Cloud Review. Now would be a great time to check out those extra resources on your console provided by our sponsor and the stuff that was provided by Ian. Remember, we're giving away a GoPro Hero 9 action camera to one lucky attendee at the end of the third session, but you must be present to win, so stay tuned. Back in a few.
Welcome back to our second session. David, please take it away.
Okay, welcome back, everyone. Thank you for being here. Thank you to our speakers and to John K. Waters for moderating that first session, and, of course, Red Hat for underwriting this summit and allowing us to bring you this great content. I'm David Rammel, editor of Virtualization and Cloud Review, here to moderate the second session of our summit called AWS Security, Backup and Recovery Best Practices. Our speaker for this session is Carlos Rivas, Senior Solutions Architect at Intervision Systems. Carlos helps California community colleges move their traditional data centers to the cloud. Over the course of his career, he has worked for several large telecommunication providers, managing and configuring network devices using numerous tools and languages, including Java, Groovy, Python, Perl, and PHP. He's also a cloud computing instructor for LinkedIn Learning and Udacity. Carlos, it's great to have you here. Please take it away.
Thank you. Good morning, good afternoon, and good evening, depending on where you are in the world. And it's a pleasure to be here. And not only we're going to connect today, but as you can see, I put in my LinkedIn profile link there. So if you have any questions around DevOps, cloud, feel free to contact me. I'm more than happy to help out. So let's get into the content today. We have plenty to discuss, and we have a lot of users submitted questions. So we're going to get to those as soon as we get through the presentation. We're going to be talking about security threats, threat mitigation, disaster recovery, backups, and, of course, followed by the Q&A. Let's start right away by talking about security threats, because that's a really, really hot topic these days. Keeping your environment as secure as possible, especially in the cloud. If you are not following best practices, you could be exposing your data and your users to potential risks there. So it's good to be up to date around the topic of security threats and make sure what exactly are you fighting. So we're going to start with this quote by Werner from AWS, and he says that everything fails all the time. So exactly what does this mean? It means that if you're designing a system, you cannot pretend that your web server or your database or everything is going to be running fine all the time. You have to have a plan for when things actually fail, which is just any time, at any moment, for any reason. So you have to assume that, the physical hardware is going to fail, the virtual machine is going to fail, you're going to get some sort of attack, you're going to get a denial of service. Something is going to happen that is going to prevent you from providing the service that you provide to your end users. It could be something as simple as you're running a sale and you have all users coming in at the same time to your website, and it simply crashes the server. So always design your systems to handle this type of situations. So exactly what is popular right now in the world of security threats? I've made up this list right here, and this is an ever-changing document, so I just pick what I consider to be top 3. Some of these are probably not really a surprise for you. For example, password security has been an issue ever since passwords have been used in computer systems, 10 years, 20 years, 30 years and more. It's just a constant issue because of the human factor. Some people are just too lazy to go beyond password 123 or something, something like that, or put in a complex password in a Post-it note where everybody can see it. Those things will always be there, and you have to, protect yourself against those type of situations. Now, there is a number 1 here, and it says ransomware. And I'm sure you would agree with me that you've seen this word ransomware in the news way too many times in recent weeks and months. Like some person got a ransomware attack and they encrypted all the data. Like, what do we do now, right? That word's just been thrown around way too much. I'm going to talk about potential ways that you can prevent this from happening to you, and some tools as well. Denial of service is also one of those that's been around for quite a while. It's simply collecting an army of small compute units that are going to hit one or more of your infrastructure components. Whether, it could be a web server, it could be your DNS server, something like that. And by creating this attack, it will prevent authentic users from using your service. Now let's talk a little bit about ransomware, for example. The definition would be that it's a type of malware that threatens to publish the victim's personal data or to block access to it until the ransom is paid. So in this case, they'll send this piece of software that goes after your infrastructure, and when this happens, it will use some encryption just to collect all your data, put it behind this encryption paywall, if you will, and then pretty much, you're pretty much trapped at that point unless you have some sort of a backup in this case, okay? So it's just something to keep in mind when protecting your data. So like, okay, we just lost our data, it's encrypted, we have to pay this ransom, what do we do? In this case, the solution we're going to get to in a moment, but I'll give you a heads up, it's keeping your backups in an air-gap environment, okay? So in completely isolated environment away from where these attackers are currently attacking. Now, denial of service, the actual definition would be is when, somebody makes a machine or network resource unavailable to its user by temporarily or indefinitely disrupting services of a host connected to the internet. And I say a host, it could be your web server. Like I said, it could be a DNS server. Anything that is receiving traffic from a public source and is exposed to, potential bad actors hitting that host. So in this case, there are options that you have available, especially if you're in AWS. I'll give you some of those options here in a moment. But just know that, yes, it's always good to have, this first line of defense, perhaps a secondary line of defense. And those types of situations, those types of scenarios will protect you from this type of things. Because this is one of those things that is always going to happen. There's nothing that you can do about this. You're always going to be exposed to a denial of service attack. Now, everybody's favorite, password security. There's really not much we can do about this one. But I'll give you some of the main issues that we're dealing with. Number 1 would be not enforcing multi-factor authentication. So in this case, you have users, you give them credentials, and then perhaps you say, okay, you're forced to change your password every 30 days. That's fine, but you have to enforce multi-factor authentication. That's really a way to, keep that number 1 security policy in mind, which is something which is the password, and something you have, which is the multi-factor. Usually their cell phone or, like a key sent to their cell phone or a a rotating application like Microsoft Authenticator or something like that on your phone. So yeah, if you're not using multi-factor authentication, you're really, really exposing yourself to potential breaches there. Poor password policies, and I would like to pair this one with too strict password policies. And let me explain why. When you have a too relaxed password policy, people are going to exploit that. They're going to do, as I just joked about, like password 123. If your system allows that, you can be sure that people will use something like that. Conversely, if you have a too strict password policy, kind of the same will happen. If you are one of those that enforces, you need to have uppercase letters and lowercase letters and numbers and symbols. If you make it too complex and people don't use a password manager such as Dashlane or LastPass or something like that, if the password is too complex, it will end up in a Post-it note visible somewhere, and that also creates a security issue right there. The solution for this would be a single sign-on, and we'll get to that. So that's why I put it here. Not using single sign-on, kind of, it's a potential issue there. But if you can get away with using single sign-on, it will, pretty much offset all the other problems here. Now, other common attacks, other than the one I just mentioned, like passwords, ransomware, all that stuff. You have phishing, which is when you get emails that require, some urgent action, and you don't realize that the email is fake, and you end up typing your password in what appears to be a legit website, and it's not. So this is usually on top of mind for system administrators, especially managing something like Microsoft Exchange, email servers, and things like that. SQL injection, this is more for you software developers out there. This is what you would have to consider if you're taking input from a web form or something like that, where you collect data and the data may contain malicious code in it. You have to obviously sanitize your data before sending it to your database to avoid issues like this. Man-in-the-middle attack, which is the most commonly known as you're sitting at a cafe like Starbucks, and then somebody's monitoring the traffic and the free Wi-Fi, and they can, capture your network packets that way. Denial of service, we discussed that as one of those that, you're exposed to it, whether you want it or not, because it's just, I guess it's one of those things that is always going to be there, especially when your business starts to grow. People are going to try to take it down, just to mess with your the ability for you to provide your service. And one that will probably never go away is the USB flash drives. And I'm sure everybody here has to, if you've taken any of those mandatory security trainings in your company, they will always mention that if you ever find a USB drive in the parking lot, do not stick it to the computer because reasons, right? Those usually have some sort of malware attached to it that is triggered by the plug-and-play functionality of certain operating systems, and it will basically take over your computer as soon as you plug it in. Now, what can we do about all this stuff? Let's see some of the options that I've gathered here to protect yourself from all those threats that are out there. I have load balancing on firewalls, which don't really sound like too much of like, what can I do with the load balancer, right? It doesn't sound like something that would be a security component. It sounds more like an infrastructure component, right? Well, load balancer, it can help you distributing the load. So, if you have several web servers, not just one, because, it's going through your load balancer, and if you're using a load balancer provided to you by AWS, for example, in this case, they can see the attack patterns. They can see where the traffic is coming from. So, they can really help you mitigate some of this distributed denial of service attacks. It's like having, as I mentioned earlier, having an extra layer of protection in front of your infrastructure. The same thing goes for a firewall. Yes, you can manage your firewall. Yes, you can put in your your own rules, and those rules will protect you from, traffic that is not authentic users, but also because these services are managed by AWS, they have dedicated employees 24/7 monitoring these services and looking for, all these kind of traffic that is clearly not legitimate traffic, and, filter it out for you. Here's an example that I have for the load balancer. I believe this architecture is called a web access firewall sandwich, where you have a load balancer that sends traffic to a first layer, and that first layer is going to really be there just to authenticate and make sure that these are not IPs coming from a certain range or a certain geographic zone that is known for attackers. And once all this thing is filtered out, it goes to another load balancer that actually will send the traffic to your actual application. So, again, as I mentioned, this is like 1 layer, 2 layers, 3 layers. All these layers, you're just filtering out bad traffic so that your web servers actually receive authentic users. Autoscaling is something that you would pair, in this case, with load balancing. And this is something that most people would not think as a way to protect themselves against a denial of service attack, because autoscaling obviously is just going to start spinning up more and more servers to be able to keep up with the demand. In this case, quote unquote demand, because it's a denial of service attack, so it's essentially fake traffic. I can tell you right now, do not be afraid to use autoscaling in AWS.
Please stand by as we reconnect our presenter.
Okay, sorry about that, folks. We're working to get Carlos back online. These presentations have a lot of moving parts. People are calling in from all over. For example, I'm in northwest Montana. Let me know if there's any Montanas out there.
Please proceed.
Okay, we're back?
Yes, sir. So I was talking about autoscaling, David. And can you see that slide?
Yes, autoscaling is up.
All right, so I'll move on. The next one here, it's what I was saying is that autoscaling, never be afraid to use it as a tool to protect against those denial of service attacks, because autoscaling, when AWS knows that you're scaling because of a denial of service attack, they will not charge you for, like, oh no, like we know you don't have to pay for this. This is an actual attack, so you will get actual credits for using autoscaling in this type of situation. So it's not like you'll spin up 100 servers and they'll be charged for those. It wouldn't be that way. So it's something to keep in mind when it comes to autoscaling in that sense. Now, this architecture here is a little bit more involved, and it uses autoscaling as well. But I'm throwing in an additional component here called Amazon CloudFront, which is something that you would use for content distribution. And again, somebody would not think to use CloudFront as a way to protect themselves against an attack, but it goes back to the same reasoning of the load balancer and the web access firewall, in that CloudFront will, because it's a service managed by AWS, they have a team 24/7 monitoring traffic coming to CloudFront, and they can see when some bad actors are trying to hit that particular endpoint, and they'll filter it out for you. So it's also a great component to add to your application. If you have a public-facing web server, for example, combine it with load balancer and autoscaling. But if you throw in the CloudFront in front, you have this additional layer of protection. So in the end, you have so many layers in front of your application that you would think that, it's probably going to slow down a bit. Yes, you might add a few milliseconds of latency to your application, unfortunately. But in the end, you'll get true and certified traffic to your web servers, as opposed to, having to deal with just all these unauthenticated traffic, right? Now let's switch gears a little bit to talking about disaster recovery and backups. So talking about disaster recovery is basically having a design or the ability to have a system that when a failure does eventually occur, you have the ability to go back online as soon as possible, as soon as it's practically possible. Because actually, at the time of this presentation, you probably know that the entire Facebook network was down due to a BGP routing situation that they had, and it basically took the entire day to recover that. So it was a BGP routing error, and like I said, if they had some sort of plan, it probably did not include BGP routing errors, so because they essentially lost millions and millions of dollars for that particular outage. So in what pertains to our conversation, I'm going to talk about an air gap, and this is related to backups. So an air gap computer is one that is neither connected to the internet nor connected to other systems that are connected to the internet. So the goal here is for your disaster recovery plan to have a way to store backups in an isolated environment, namely an air gap. And this environment is going to be completely separate from what you have. So that way, if you get compromised, there's no way to access your data. I always like to use this graphic for this purpose. What this means is you have a system, and the system is collecting data, usually in a database or some other storage. And once this data is collected, every few hours or once a day or once a week, this data is sent to an air gap location. And this is a location that is going to receive data in one way and one way only, right? There's no way to get it back unless you enable, like, hey, we are in a disaster recovery scenario and we need our data back. Now, why does it have to be a one-way connection? Because if your systems get compromised, you can be sure that there's no way to pull data out of the air gap system in this case. So your backups would be safe in the event of a hacking event or, data leaks or something like that. So it's good to have that. And the best example for this is, of course, as we mentioned, the ransomware situation. Somebody says, hey, you have to pay ransom. And then you would say, no, we're not. We're not going to pay anything. We're going to delete the entire data that was compromised. We're going to start from scratch, and we're going to pull from our backup, which is air gap, and it's safe from the whole ransomware situation. So now, time is an important factor here. So I remember in the news the same thing happened when the ransomware attack happened to the, I think it was a power plant or no, it was a gas provider. And the thing is, yes, they try to restore from backups because they had backups. The thing is, if it takes you so long that to restore from your backups, that you're going to be losing millions of dollars anyway. So, I hate to say this, but it could probably be cheaper just to pay the ransom to get your data back. So, and we call that in the industry the RTO, the recovery time objective. And of course, it is very closely related to the RPO, which is the recovery point objective, which means how old is the backup, right? You want to, because sometimes you need data to be available as closely to real time as possible to the time of the event, the disaster that actually happened. So those two are closely related. Most businesses are okay with, a few hours of downtime, no problem there. So you can plan and design your backups around a few hours. But if you're going to be out more than a few hours, it can get very, very expensive very quickly. So in those situations, what you can do is create what is known as a hot standby, where you have like two systems, like right then and there. This would be a good example, for example,
of a hot replica where you have a master database, but you have a standby, and that standby is always synchronizing, always synchronizing. So if something were to happen to your master database, and it were to crash or something like that, you know you have your standby database available and ready to go at any time. Of course, the more real-time you need your backups, the more costs you're going to incur, obviously, because basically you're duplicating every resource that you have in a different data center for the sake of availability. So you have to balance costs with the RTO and RPO that we talked about. This is what I call the completely active or completely hot disaster recovery environment. This is where you would have pretty much an exact replica of your system in a different AWS data center or availability zone, for example. You'll have these two systems, again, completely identical, with the exception of the backend database, which is set up to real-time replication, pretty much just like we saw in the previous slide. And then with that replica, if something were to happen, like a storm or something that takes out a whole data center, your application is still available in the other data center or region, if you will, and everything will continue to run just fine. Again, of course, the limitation here is that your budget would essentially double because you're paying for double the servers in this case, more double from what you exactly need, right? So looking at this scenario, for example, this is more related to the actual architecture. And this is something that I promote a lot. This is called the well-architected framework, where you will have separate accounts depending on exactly what you're doing. And so what is the actual benefit here? This is more related to the air gap, to be honest here. The air gap is created because you have separate AWS accounts that require separate security permissions and perhaps completely different users. I can see one here, for example, the one that says log archive and security accounts. Those would require a little bit more privilege to get in there than, for example, your actual application or shared services, something like that. And in those cases, like I said, this creates what we call a smaller blast radius. So if one of your accounts gets hacked, let's say the shared services account gets hacked, well, those people will not be able to erase their footprints because all the logs will be in the log archive, which is a completely separate account, and that requires completely different set of credentials that they would also need in order to be able to, cover their tracks, right? So, yeah, this is how I would implement something like an air gap in AWS, providing everybody with the ability to write to the log archive account, but nobody can pull data out of there except for maybe one or two admins that have the necessary permissions there. So how do I learn more about what I just talked about? There's actually an AWS white paper, really, really good, and it's actually required reading if you're going for any of the AWS certifications, especially at the professional level. And it's called Disaster Recovery of Workloads on AWS. And it basically covers every one of the architectures that I just talked about there in that document. Now, that last slide is called the Well-Architected Framework, and that's essentially my number one go-to document at all times. This is what I use all the time in my work. So there's also a white paper for that you can read in the AWS official documentation. Now let's dive in a little bit more specific about what options do you have when it comes to AWS backups. The number one and most obvious is something called AWS Backup, although I have to tell you that this is probably a little overkill in most situations, unless you're running like many servers, more than a dozen servers. In that case, AWS Backup may be for you. But essentially, this is a tool that provides, all the necessary, to make snapshots, to back up your database, your EFS drive, anything you need back up, not only EC2 machines, but also database themselves. You can do that from here. And not only that, but you keep rotating your backups, because it's not only about creating a snapshot, but about creating incremental snapshots. So you're not really wasting money creating the same backup over and over, but you're doing like differential incremental backups. So you only pay for the difference from the delta from the previous backup to the current one. You just whatever change is that it will create those little backups for you. So, and of course you can manage the frequency. You want it daily, you want it every hour, you want it every 2 hours, all that. And then the expiration date of those backups, because of course you don't want to have, hourly backups forever, right? So you can make them expire and delete them as needed. This is the Data Lifecycle Manager. It's something that I use a lot more because this is not overkill. This is something that I use absolutely all the time. So if you have a regular machine, I always go to my favorite example, a web server. If you have a machine like that, you can set up the Amazon Data Lifecycle Manager to back up the drive of that machine, as I mentioned, maybe every 4 hours, maybe, 3 times a day, 4 times a day. And then with a tool like this, you can do all this stuff, like, data retention and reduce costs by deleting the outdated backups and use it for disaster recovery. So, and also creating standardized machine snapshots, which is really the end goal here, to be able to create a machine image that you can use in the event of an actual disaster. You can say, okay, let's take this backup and restore the machine to the last known good state. So probably recommend this a little bit more than AWS Backup. Just remember Data Lifecycle Manager. One more option, but this option is more for the enterprise and specifically on-prem, is the storage gateway. It's essentially another virtual machine or quote-unquote appliance that you run in your local data center, and behind the scenes, it will be connected to Amazon S3, for example. So what this means is you have this appliance running locally, and it's essentially backup software, right? So you can say, hey, I want to back up all these machines, and this is great if you don't want to mess with cloud or do anything like that. You can have this appliance running within your data center, and it will just manage your backups locally, and behind the scenes, it will do all the necessary transmission to get this data safely to AWS. It will be completely transparent for those using the local network, so it looks just like any other local solution for backups. So this is great if you don't have people that are well-versed in cloud. This is a great solution for that. Of course, obviously, for this to work, you need some kind of connectivity to the cloud, and all that needs to be set up ahead of time. But, once it's set up, like I said, it's just a really, really great tool for enterprise backups. And one more when it comes to backups would be a third-party solution. There are plenty of software solutions out there. I can think of 2 or 3 right now, that what they do is several things. They'll take snapshots of your virtual machines and save those snapshots in the cloud. The same thing for data. If you have like a database, that database will be snapshotted and moved to the cloud. The goal here is more for disaster recovery, not really for backups. So in this case, let's say that you lose virtual machines due to a disaster, or perhaps, as we mentioned earlier, like a ransomware attack or something like that, you can just say, delete those machines, we don't care, and then this software will do essentially the reverse. It will go to the cloud, it will take the latest snapshot that survived, obviously, and then bring it back from there to your on-prem. The reason why you would pay for a solution like this is because they essentially do everything for you. In other words, they'll make sure that everything is exactly as it was without any need for human intervention in this case. So it's completely hands-free solution. There are several of those, and they're just absolutely great. It's one of those things that is good to have if you have critical applications and you have very low RTO, RPOs that you need to meet for your disaster recovery requirements. So this is absolutely a solution that I recommend. So what key points can we take away from all this backups and disaster recovery? It would be that you need a backup strategy, whatever it may be. I mentioned several options such as do it yourself, use a lifecycle manager, use a third-party software, but you need to choose one and stick with it over the long term. One thing about disaster recovery plans is that unless you execute your disaster recovery plan every now and then, you don't really have one, simply because, if you want to be back online, let's say within 2 hours of something bad happening, you want to at least try that a couple times a year, saying, hey, I want to do this. I want to make sure that everybody involved knows exactly what to do when the systems go down so that we actually recover within those 2 hours. And if you don't practice that, those 2 hours could easily turn into 8, just like happened to Facebook this week pretty much. Something else here would be to use CloudTrail. CloudTrail is a tool that is going to keep track of all your activity in the cloud, just so that you can always know, like, hey, what happened and who did this. If you need to know who did something, CloudTrail is going to be your tool. And this is where the well-architected framework comes into play, because you can say, well, these logs, which are audit logs, they need to be in a separate environment so that nobody else can delete it, because, there's nothing more disturbing than finding that something changed in your AWS environment, and when you go to the logs, there's absolutely nothing there. So you got to protect those audit logs for sure. And remember to use firewall rules and least access security groups. I know it's very, very convenient to open up a web server to the whole world, or open up, like an SSH connection to a server that anybody can connect to. But, it's a hassle to do it IP by IP based on like the IPs for the remote workers. But it's a little bit more protection. The more layers you have to cover your servers from the outside world, the better in this case. Just firewalls, but also load balancers and CloudFront and auto scaling, all that stuff that you can throw in to make sure your environment is safe. So what can you do absolutely right now? Number one is enable multi-factor authentication if you're not doing so already. Something like Microsoft Authenticator, or using a third-party solution like Ping Identity or Okta or something like that, right? And if you have an AWS account, I need to remind you that you do not need to use your root account for anything. Once you set it up and you put in your credit card information, set up your billing and everything, just delegate, just create an admin user and lock away your root account. You don't need that account for anything else other than account management. So, do not use those permissions. Just make it a really, really complex password and put an MFA on it, and just don't use it at all. The same goes for reducing entry points into your environment. As I mentioned, just restrict based on IP addresses, number of users, as little access as possible into your environment. And that's something you can do simply by identifying the people that need access to your environment. In that same line of thinking, avoid using IAM user accounts, because what happens is you'll create a user and it's usually full admin rights, and then you forget about it and you forget to change the password for 6 months, and that becomes a security breach there. So something to keep in mind. And if you need permissions from within one of your servers, just assign a role, an IAM role, to that server, as opposed to creating IAM users that may end up with hard-coded passwords and keys that are going to be in there, and those could be easily stolen, and then you would be in a bad place. So it's always a best practice within AWS to prefer IAM roles when providing access to resources to your servers or users if possible. And right now, David and I are going to field some questions, and we have a ton of questions that came in earlier from you guys, so we're going to have a long conversation here. So, David.
Okay. Great job, Carlos. And I'd like to remind the audience that we can answer questions until about 5 minutes to the top of the hour in order to give you a short break before the next presentation, so send them on in. And like Carlos said, we have a bunch of them, so let's just get right to them. The first one from the audience came in early in your presentation, Carlos. You were talking about the different kinds of attacks, and you mentioned the man-in-the-middle attack. And an audience member is asking, doesn't HTTPS mitigate the risk of man-in-the-middle attacks? It's my understanding that it does cut back on them, but they are still possible. Is my understanding correct?
I would 100% agree with that, because HTTPS, basically what you're saying is you meet the requirement of encryption in transit. That's the goal of SSL or TLS or HTTPS, is to have that requirement met of being able to encrypt data while in transit. So yes, I agree. One thing I would caution, though, is that there are several versions of man-in-the-middle attack. For example, one that is not super common, but it does happen, is like you would go to a public place, and in that public place there's a bad actor, and that bad actor is actually transmitting a free Wi-Fi signal, and they would name that Wi-Fi the exact name of the business. Let's say that you go to Starbucks and this guy has a Wi-Fi call free_Starbucks or something like that, and people will see that and connect to that network, and now you're in trouble because now you're directly connected to the person's machine, and they can see every single network package that you are moving through. So that's something to keep in mind. So it's always good to have your VPNs ready to go, especially when you're doing work off-site. Have that VPN enabled at all times, and just in general, if you can avoid public networks, just do that, right? Cell phone networks these days are quite reliable, so you can just tether from your own cell phone, use it as your own Wi-Fi hotspot to avoid those type of situations.
Okay. Next question comes from Eric in the audience. If you're replicating from the master DB to the standby DB, how does that keep the infection from pushing to the standby?
Well, in the case of a database, database data, because the thing is, if you're talking about ransom itself, not the data, so they'll try to log into the server. Once they're in the server, they can execute code that will encrypt everything. But the encryption is at a layer above that, so it will not really affect the data. However, if they gain access directly to the database, I can tell you that they will not harm the data or destroy the data themselves, because obviously that's what they're trying to steal. They're not interested in destroying that data. Another thing I can tell you is that it will trigger what do they call it in Microsoft SQL Server? It's like you have an open transaction and you have all these update statements, changing record by record. Let's say that they do get into your system and they know which table to go for. Let's say call it customer users or something like that. And they will go in there and try to encrypt every single one of them. It will generate too many transactions all at once, and it will trigger a transactional issue in Microsoft SQL Server, for example, if this what's being used in this case. So the replication will not happen instantaneously. But let's say that your scenario is actually happens as it is, and your standby is destroyed. That's why you would have backups. And then you would pull from the backup in this case and destroy intentionally destroy your master and standby and just pull from the backup in this case. You obviously lose whatever data happened between the last backup and the current moment in time, but it's better, than dealing with the actual attacks.
Okay. Next question comes from Andy. He's talking about air gap, which you mentioned in the context of preventing ransomware attacks. He says, how does air gap prevent malicious actors from overriding, encrypting protected data if your configuration only allows one-way direction to air gap from the data source?
First of all, the design in this case is for sending data only. So it's not like the database example, like we just mentioned, like you can interact with it and destroy individual records and do things in there. So the air gap is simply, we can call it a TCP connection or an open API or something like that, where a backup or something will happen on your end only, okay? And when it happens, this data will be considered ready to go, and then it will be picked up by either an application of yours or a third-party software that will actually send this over the wire to the air gap location. So once this data is on the other side, it's not like the database example that we just described. So it's not like it's just going to blindly overwrite, just take this data and overwrite whatever we have. It will be a version control system, kind of like we have in AWS S3. Well, yes, you will overwrite, and this new data will become the latest version. But if something were to happen and you contact your provider and say, hey, I need my data back, you can tell them, hey, the latest version that we send you is a malicious copy. Can you destroy that? Let's get the previous version. So that's one, the air gap is not just the network portion of it, but it's also the permission side of it. So the data goes over to the secure environment, but it's also not necessarily like 100% trusted right away, if you know what I mean. So they don't say, okay, this is the data, let's roll with it. So it's you get several layers of protections, not just the networking air gap in this case.
Okay, next question. How do you implement DevSecOps in the government cloud?
Oh, that's great, because I actually have one customer in GovCloud right now. What we do is we have several tools. Well, one of the limitations of GovCloud is that it doesn't move as fast as the regular commercial AWS Cloud. So there are tools that you're not going to have there. I believe AWS Backups is one of those examples. So there are things that the same year they're released, they're not necessarily available in GovCloud. So you have to work around the limitations that you have. In my situation, what I have is an environment that uses full-on CI/CD for infrastructure as code, and it's all running on internal servers. There's no outside connectivity here, so for security reasons, obviously. And everything is automated. So when it comes to DevSecOps, the number one thing is automate everything, including a piece of software that checks for vulnerabilities and stuff like that on the CI/CD pipeline to make sure that everything you're pushing to production is already tested and secure.
Okay. Here's an interesting and quite specific question. How do you secure pre-release high-resolution media content in AWS?
I remember that question, and it really relates to me because I produce content all the time. So in this case, AWS has a lot of tools. I can name one right now, Media Encoder, for example. There are several tools that are specific to handling media in AWS. In the end, they all end up in the same place, which is AWS S3 for storage, which obviously there's no choice. If you're handling, let's say, a 4K video file, there's going to be several gigabytes in length, in size. You're definitely going to need something big and cost-effective like S3. So my advice is get really well versed when it comes to S3 bucket policies. And if you need to share anything outside of S3, outside of AWS account, use what is called expiring URLs or pre-signed URLs in AWS. So what that means is if you need to share the file with somebody else outside, through the public internet, just give them a URL and tell them this URL you can use to download the file, but this URL is going to expire in 3 hours, for example. So you give them enough time to get the file, and then the URL is no longer valid. If they miss the time window, they're going to have to contact you again. But this is way better than exposing your data to the public in general. So it's always use this tool available to you. And in the bucket policies, you can specify the IP address of the person, so that way they cannot share the URL with somebody else because it will be tied to that specific IP. But of course, the IP you have to do in a bucket policy, but just know that you can do that. You can have several layers of protection to share files with the public, with at the same time preventing, piracy or unauthorized access.
Okay. All right, Carlos. You're just plowing right through these questions.
Yeah.
Looks like we have about 5 more minutes, so let's see if we can get to all of them. Awesome. Next one. How to detect EC2 launches to mitigate risk of cloud cryptojacking.
In that case, I use a tool called AWS Config, and Config will let me know with proper alerts whether somebody just launched an EC2 machine within my environment. It doesn't matter if it's the local region or if they're doing it halfway across the world. If somebody launches an EC2 server within my account, AWS Config can generate an alert for me. If you want full automation, there's something called AWS Guard Duty that will do exactly the same. And it will, monitor config for these types of unusual behavior, and it will generate alerts that you can act upon.
Okay. You talked about AWS's built-in security constructs and things like that. And here's a question from the audience. How can we automate security in the cloud with AWS?
There are several ways. I can tell you 2 right now. You can use the AWS provided tool. The number one would be AWS Security Hub, which is a tool that looks for best practices within your account. And if it finds things that are outside of those best practices, it will generate a report, such as passwords that hasn't been changed in too long, ports that are open that should be blocked or, limited to certain access. Those things like that you can do within AWS using Security Hub, Guard Duty, and similar tools. Outside of AWS, I would recommend, it really depends, but of course there are tools that you can integrate, scanners and vulnerability checkers to your CI/CD process. For example, if you're working with containers, you can use certain tools that you can build into your CI/CD pipeline, and those tools will actually look for vulnerabilities within your containers even long before you push them to your repository. So it really depends on the particular task. But yeah, there are, for example, if it's within AWS native, I recommend Security Hub there.
Okay. Next question. What are emerging trends in cloud security?
Well, number one right now is the hottest thing is ransomware. So be sure to either find a third-party solution. I believe Clumio comes to mind as one of those. But yeah, within AWS, I don't think there's anything in particular that you can do about something like a ransomware. But designing an air gap by yourself using a standard AWS architecture is not that hard at all, especially if you just follow the well-architected framework. Just following those guidelines, you can use those guidelines to, use something like AWS Backup or something like that to get yourself set up with an air gap system by yourself, if that's the way you want to go.
Okay. Here's a question. Can you talk about AI applications in business and government?
Absolutely. When it comes to artificial intelligence, the number one thing would be anomaly detection using machine learning. So in other words, you don't have to say, hey, if we cross this threshold, that means there's something bad going on with the system, or we're being attacked, or this document is bad. None of those things. You can actually just train a system using machine learning to be able to detect fraud and to also detect crazy patterns that may be happening. What do I mean by that? So if you have a bunch of documents that are fake, applications to your website or something like that, you can feed this data into a machine learning model using a tool such as AWS SageMaker, and you can train it to do a binary on those documents, give you a yes or no, or okay, or go, no go, and it will give you certain level of reliability that you can use. Of course, you'll have to screen every now and then because you'll get some false positive and things like that. It happens. But yeah, that's something that you can do. The other one is anomaly detection in monitoring. So if you have an unusual spike in CPU usage, or too much memory usage, and those things that could lead to a memory leak or a system crash, you can detect those early using anomaly detection, which is already provided by AWS within CloudWatch. So you don't even need to implement it. You can just readily use it right now.
All right. Let's squeeze in one more quick question. You talked about this earlier, but maybe you can just review briefly. Who's responsible for data security, AWS or their users?
That's great. I believe that came up in the previous presentation, and it goes back to the AWS security model. AWS will provide you with data security, physical security for your server. They'll guarantee that there's security guards and motion detectors and very limited access to the physical machines where your data resides. But when it comes to the operation task or the machine, let's say that you have a web server and you need to put a public IP address on it so that the whole world can see it, at that point, it becomes your responsibility. So the access to the logical side of the server, it depends on the end user. That's their responsibility. And AWS takes care of the physical aspects of that security so that nobody can touch that machine except for the authorized personnel.
Okay, great. Looks like that's all the questions we have time for. So thanks again, Carlos, for a great presentation and answering all those questions.
Thank you. It was awesome.